So if you look at the current enterprise architecture, I talked about it a while ago. In the data center, you want to publish a service, could be email, file server, whatever service. You borrow a bunch of these services, commodity compute, provision some LUNs on your storage, attach a snapshot and a DR policy, plumb them together via VMware and some networking, and you have your service ready to go, right? But again, back to the same question, in the modern world, what happens is enterprises get distributed. When they get distributed, you start creating these islands of storage, right? And this can be a local file server, this can be a local SQL server, whatnot. Primary motivation for this is, what if the WAN gets disconnected, right? I don't want these people out having coffee. I want them to be productive. Let's give them a local copy and we'll back that up. And if there's high latency, we aren't able to consolidate anyway, push the infrastructure out, right? So what do we do with SteelFusion Platform, right? Or previously the Granite platform. What we do in that case is, you have in your remote location, you have servers, you have some storage, you have some backup, right? We introduced two appliances, which is the SteelFusion Edge and the SteelFusion Core. And what we're able to do as a result of that is consolidate all that storage back to the data center and be able to project that storage out from the data center as if it were local storage in your branch office, right? And what we're going to do today is going to go into the depths of how the SteelFusion Edge appliance, which is the converged infrastructure appliance shipped to your branch office, works with its counterpart SteelFusion Core, which is what I call the storage broker. Right? What you do is on your back-end storage at the data center, you provision LUNs, you give it to the storage broker, and the storage broker says, okay, this LUN goes to that location, this LUN goes to that location, this does go to that location. We'll get into the mechanics of it. Absolutely, those questions are arising in your mind, but from the basic philosophy of it, what this is doing is basically acting as it takes your storage from the data center, from any back-end storage platform, NetApp, EMC, 3PAR, whatever choice of your block storage of the data center, and project it out to various different edges.
Can SteelFusion coexist in the same hardware appliance of a Steelhead, or it's a different appliance?
It's a good question. So SteelFusion Edge, basically, we have something called the remote infrastructure appliance. That remote infrastructure appliance has three components. It's got the Steelhead, which is the optimized networking part. It's got SteelFusion Edge, which is the storage management part, and it's got ESX embedded in it. So it's the converged infrastructure appliance, but instead of having plain vanilla networking switch integrated to it, it's got a Steelhead integrated into it. And Steelhead is there primarily for the optimization of all this traffic that we're going to talk about today. So how does the architecture lay itself out, right? So this is the question that you ask. So in the data center, you typically, when you deploy an application, you got your storage administrator, server administrator, virtualization guy, backup guy, and the networking guy, right? And then in your branch office, when you have your consumers, we ship the SteelFusion Edge appliance, right? Again, this question that you asked, SteelFusion Edge appliance is actually divided into three planes. And for illustration purposes, basically, this is a single appliance, but I've broken it out, right? It's got ESX, standard vanilla ESX in it. It's got the SteelFusion Smart Edge Cache in it. And we're going to go into the details of how this edge cache works, actually, to give you the illusion of LAN-based storage in your branch office, which is actually borrowed from the data center. And then it's got the optimization technology built into it, which is the Steelhead. So you can have the Steelhead separate from the SteelFusion and the compute plane as well. But typically what we've noticed is a lot of customers want to collapse the infrastructure down to a single box in their branch office, and that was our motivation of going out. But traditionally, customers that just have Steelhead in their branch office and want to replace their storage and servers, they can buy the SteelFusion appliance with Steelhead deactivated. And when they come up to the refresh of their Steelhead appliance, we just activate the basic license and they can retire the old Steelhead and get the new converged appliance, right? So now we're going to get into the details of how all of this works, coordinated all the way back to the data center. Any questions?
No, move on. Keep going.
We got about 30 minutes. Is that the time stack you said?
So this is the SteelFusion stack. So we provision the broker at the data center. The broker mounts the LUNs from your back-end storage appliance, NetApp, EMC, whatever is the flavor of the day. And then Steelhead, and using the Steelhead, it projects that cache out towards the remote edge, right? So that's the advantage of fully consolidating storage, because now you can run your snapshots here, you can run your backup policies here, you don't have to run replication, you don't have to run distributed licenses of your backup environments. The applications make continuous changes at the edge. We replicate those changes back to the data center. We're going to get into the details of the performance as well, but typically a common question that I get asked is, well, how far behind is the source LUN from the edge? On a typical DSL line in my customer install base, I've noticed about 2 minutes behind. Depending on obviously the change rate. If the change rate is very high, then some writes can get clogged up, but obviously what we have noticed that steelheads do a pretty good job in keeping it well within syncable reach. And the RPO, recovery point objective, is down to minutes as compared to hours when you're running a replication job back and forth. Then obviously once we project the storage out at the remote site, this storage is projected just like a local data store, which is actually coming from the data center. So the locally running virtual machine looks at it, oh, this is my local storage, but actually the storage is coming back from the data center. So how does this block projection work? At the end of the day, so we separate storage and compute. You provision LUNs on your your backend SAN. You project the LUNs back to the storage Granite core or SteelFusion core device. So core acts as an initiator just to every other storage back at the data center, mounts the LUN, and then your storage administrator and virtualization administrator logs in here and tells them these LUNs go to these remote offices. A lot of the times, so what is so different about this caching as compared to other caching? Because remember, we are caching across the WAN, right? So the penalty for a miss is very high, right? So that's why the block cache that we push out in this solution is actually file system aware. So we actually resolve dependency chains of file systems to be able to figure out very quickly what is the working set of your application, right? Typically, if you log into the management screen of a storage appliance, you're using about 20% of storage. The rest is just long tail archival data. 20% of your working set is extremely active. Now it changes from day to day, from financial quarter to financial quarter, but it typically remains at that 20% range on a per application basis. What we mean by file system awareness is that we understand the two most commonly used file systems in the branch office. Those file systems are NTFS and those VMFS. That allows us to project and run these virtual machines from the data center out at the edge in the remote site.
Quick question. You said when it's mounted on the branch side, it looks like a local data store. Did you mean local to the site, or like ESX sees it as it's a local data store?
ESX sees it as local data store.
So does that cause a problem for like vMotion if you have a couple nodes or that kind of thing?
So if there are multiple ESX servers out there, so we will be just one of the data store. And if you're part of the VMFS file system, we will be participating in the VMFS cluster. So people can, and vMotion is a common way we use to migrate workloads out back into the data center, because you would have an external ESX server. We'll project our data store out there to our local ESX server box, and we'll vMotion the other server onto us, and then sync it back to the data center, and we'll bring that virtual machine back that way. That's a vMotion. Accepting vMotion out at the edge is a common way to replace existing infrastructure which is already provided out there.
So you also have customer using this architecture for migrations?
For migration from the branches back to the data center once they deploy this. Right. So how the block projection and the file system awareness works, what you do is you basically go ahead and introduce the SteelFusion solution. In the branch office, you have a single appliance. For illustration purposes, right now I will draw the compute out as a
I deleted it.
There you go. For reverse illustration purposes, the compute is resident in my appliance right here. I had drawn it separately, so because we can even take the storage from the data center, project it into the branch, and our box just appears like a block target to other servers as well. If you want to have separate compute and want to be able to play with CPU and memory, right? So what would happen in this case is you would provision a LUN, we would provision a working set of that LUN out to the remote site, and then what would happen is all your reads are now coming off of locally. Right? And the way that happens is, what we do is as soon as you project a LUN to a SteelFusion appliance, what we do is at the data center, we parse that LUN. We parse that LUN to be able to figure out what the kind of a file system it is. If it's a VMFS file system, we figure it out, VMS5, VMS6. We further parse it down to figure out what are the guest VMs. It is a Linux-based VM, NTFS-based VM. Then we go into the guest file system. And then we start parsing the guest file system. Why are we doing all of this? Because we want to be able to communicate the metadata information of this out to the remote site, right? So once the remote site has that metadata information, it can sustain itself to quickly figure out what the working set of a certain application is going to be. And once I have that working set, I can sort of tolerate those transient WAN outages in the middle. But if there's a longer WAN outage, then yes, if something that is not cached locally, or if I have not resolved that dependency change, it's going to act like, oh, where that write is going to stall, the read is going to stall at that point.
What's your cache hit ratio minimum to maximum? What you see with your customers?
Typically what we do is normally what we have seen is about 80-20. But 20% is the working set, what we have observed in the cache out at the edge. But then we have also a safety mechanism built in. A lot of customers do that, especially customers like a lot of federal customers that do geotrain mapping. They stay disconnected for a longer time. So what you can do is you can even pin that LUN out towards the edge. What that basically means, we will pre-populate entire contents of the LUN out at the remote site.
You were just saying working sets. I was asking you the cache hit ratio. How much misses do you have on 100?
Right.
Maximum and minimum.
So typically what I've seen is at a customer site, less than 3% is what I see. And that the cache miss ratio. That's how accurate the system is in establishing the read set or the working set of the application. Typically we do that is, again, that file system parsing. Right? What we do, we're able to figure out what the root inode of the file system looks like, what is the file system layout structure, and how different dependency chains are resolved within that file system. And typical example of that, one of the most random workload for us is actually booting over the WAN. So you provision a LUN, that LUN happens to be a bootable LUN, has a VMDK sitting in it, you map that out to remote site. Now the cache is completely cold, there's nothing in it. And you tell ESX to boot that virtual machine. What happens is that first 4K read comes across to you, right? And that's a miss because there's nothing in the cache. At that point, the core appliance decides this is a VMFS file system. You happen to be booting a virtual machine. This is the virtual machine you're trying to boot, and here's the boot sector for it. Now, instead of pushing back just that 4K, we proactively push a lot more information along with it, so there are no subsequent misses, and that's where we're resolving the dependency chain.
Well, you still rely on the latency.
Yes, and that's where steelheads come in the middle to sort of minimize the latency.
That second request is already there.
Yeah.
Before you send that 4K, the second request is already coming.
Absolutely coming, right? So what we do, so a typical DSL line, 1.5 meg DSL line with about 100 and 250 milliseconds of latency, we take about 7 minutes on a cold cache to fully boot and a functioning server, Windows file server out there at the remote site. Right, so that's the effectiveness of it. Because and this works as a push-based cache. Whenever there is a miss, we will try to figure out all further dependencies of that miss that you could take, right? And push that information back in the hope that whatever you need, you're going to use, the rest is eventually going to fall off your cache. That's the idea for it. The other way to look at it is, if you want $1, rather than giving you $1, I'll give you $100. And then later, whatever you don't use, just return it back to me. What that is, the two devices establish between themselves something called a hinting mechanism. So when we push data out towards the edge actually gives a feedback index. You're resolving the chains in the right fashion. So the index, if it comes back 10, whatever you sent me, I used everything. You're going down the right path. Keep using that, right? If it says, whatever you send me, I didn't use anything, then basically it's a pressure applied back. Calm down, we've established the working set. So yes, the opportunity cost of completely consolidating everything back at the data center, yet being able to give completely LAN performance is 7 to 8 minutes at startup time.
So this works if you have one server booting, but if you have 3, 4, 5, 10 servers booting.
Absolutely.
And it changes also. You need a lot of caching on the SteelFusion appliance.
Absolutely. So SteelFusion Appliance comes with 3 flavors to start with right now. We're shipping a 1 terabyte device, a 4 terabyte device, and a 10 terabyte device. Another question that you asked was, what if multiple servers are booting? Typically 4 to 5 servers for an average branch office boot for us, right? File server, DNS, DHCP, and typically like a SQL database if it happens to be a retail customer or that kind of a customer. In that case, the Steelheads come in really handy, which a lot of customers already have in their network, because that's the same byte patterns going across. Because if these are all NTFS-based file systems, we get massive deduplication across them. Right? So a common question from a network administrator participating in this discussion is, how much additional load is SteelFusion going to put on my network when you're booting this infrastructure across the WAN in different branch offices?
As much as he can give you.
So ideally what we say is as much as you can give us, but the worse the WAN, the better we perform, right? Because obviously the good history with Steelheads, right? Typically what we have noticed is, once we consolidate those file servers on an average of 15 to 16 branch offices, we additionally exert about 10% more load on the WAN. And that's the usage statistics coming out of the Steelhead appliances. Because remember, we're optimizing a lot of protocols, but this protocol of running this sort of iSCSI proxy over the WAN is what we call RDisk or block stream, right? So this additional protocol block stream running in your MPLS WAN typically imposes about 10 to 15% more workload on it, depending on what the change rate of these servers are. Right? Obviously, if we are consolidating a customer's regional data center out of APAC, where basically it's just bigger of these appliances, right? Because they all get the same quick recovery, quick provisioning benefits by cloning VMs at the back end. So the ROI is definitely greater, but the pressure on the WAN is a little bit greater as well. But obviously, those customers deploy much bigger Steelheads in the pipes to crunch the numbers faster, right? On the right side, this will also go towards your disconnected operations question. Once the applications start writing on the remote side, it's a write back cache, which basically means we'll acknowledge locally and then sync the write back over the WAN back into the data center. It's from a block device perspective, it's a fully journaled file system, so as to say. We emulate a block device, but because the device can go down and fail at any time with uncommitted writes in the cache and not back at the data center, it's a journaled file system. So if we journal and we come back up and we unroll the log back to replay back to the data center to achieve a steady state. Another thing that we do consciously is we do not do write collapsing. So if you change the block 10 times, I will maintain the same write order and maintain the block sequence 10 times in order to completely be out of the way and preserve whatever the application semantics are. Another property that this cache exhibits is that there is no intelligence built out at the edge. It's a fully push-based cache, whereas all the brains of the operation is the SteelFusion core, and that is by design, so that you don't have to touch and administer this appliance out at the back end. When you provision a new appliance, as Eric was talking about, some of the recovery mechanisms that we have built in, we'll actually log, journal, and remember what was your most recent working set, and we'll push that data out first, so that your branch office or regional data center tries to come back into business quicker, and the rest can catch up as time permits over time. If the WAN disconnects, obviously we have a reserve buffer, which we don't advertise to you. It is completely changeable. A lot of our customers, especially in the federal space that happen to remain disconnected for a longer duration of time, those tweak it up to 50%, but typically it's about 10% of the local cache capacity. So the minute the WAN goes down, we start logging operations in that WAN buffer. WAN comes back up, that's the first buffer that we drain going out. A lot of the customers that run SQL databases, we ask them to run those databases in pinned mode. And that's primarily because we are doing a lot of algorithmic work internally. Nitin's team is doing that to figure out what are the interdependencies in blockchains for SQL databases or Oracle-based databases. We're doing that work. We have a prototype working for a SQL DB, but the best practice right now is to pin your databases out at the edge. A lot of people ask the question, well, if I'm pinning the database, what's the point of it? Why don't I just buy local storage? The advantage is when you pin that database out there, Your reads are served locally for complete disconnected shielding and performance. But at the same time, all the writes, the modifications that you do, we sync those back immediately back at the master at the back end, right? So you still don't have to suffer that backup problem or be able to recover locally. If the appliance goes down, don't worry about it, you got the database back here.
It's not only about going down, it's about that 3% of earlier. I don't want that 3% cache miss to go to a database.
It's absolutely. Yep. Perfect.
I'd be okay with that for recovery for a file server.
Yep.
I might be, because it don't matter how fast the file comes to you. I might be okay with that for a web server, but absolutely not for a SQL.
For a database, yes. That's exactly true. Yep. And so for another case for that is we have a SSD tier built into the appliances generally to serve those write workloads and to absorb those write bursts out at the edge. Another use that we take out of our SSDs, and that's to cut costs of the appliances, we don't use a traditional NVRAM in there. We use capacitor-based SSDs, which have enough charge left in them, so if you yank the power cable out, we will commit stuff to and retire it to the journal, and then sort of let go of the power at that point. It's just a clever way of eliminating the cost of NVRAM out at the edge, which can often make branch office appliances it's not easy to afford them. That's why typically people use servers and then have to live with the hassles of backing up and problems of provisioning. So in summary, it's a combination of deduplication over the WAN, which we borrow from Steelheads very, very heavily. It's an authoritative block cache, which is fully journaled and hot pluggable. Everything that you have come to expect from a standard storage appliance is there, with the advantage that it is stateless, right? And then all the block prefetching, the file system intelligence, building of your virtual machines, pushing those virtual machines out, all of that is built into SteelFusion Core. For all effective purposes, a quote from one of our law firm customers is, I just plug the power cable in, plug the network cable in, and I'm good to go at the edge. That's about all I need. Right? And an admin can do that at a remote office. Once the appliance comes online, Core detects it, Steelhead detects it, vCenter detects it, and you just provision from the data center. Provisioning of a standard branch office, not having a database pre-population built into it, standard file server, print server, DNS, DHCP, about 15 to 16 minutes to fully have this office up and running and in steady state.
Can you prefetch? Can you, because if that's a slightly bigger environment, I don't want to push it. Can I do that in my primary infrastructure? Take the box offsite to the branch and
absolutely.
Then, okay.
So when people do regional data center consolidation, we pre-warm the box at the data center, put it out there, and then they sync up.
Okay.
The other thing is we pre-populate. You can assign pre-population policy on certain LUNs, and the Steelheads will throttle the links at night so to get it ready for the next day to be able to work on that. And all of that is controlled from the core. You don't have to do that at the edge. You can select different LUNs. One of the commonly featured requests that we get is, within sparse LUNs, can you identify a certain file directories that I want to move out first, right? And that's for us to expose more intelligence from the raw block device. So we're kind of working on that.
No, you're journaling the writes on site.
At the edge, yes.
How do I take a backup?
Oh, that's an excellent question.
With an external backup application. I mean, not something you are applying. I have my own backup application.
Yes.
I see data on two sites with a WAN link in between.
Yes.
Tell me how I do backup.
Right. So I was not going to go into that, but thank you for bringing that up. So basically, the whole advantage is you now centralize all your backups. So what will happen is the SteelFusion Core becomes the orchestrator at that point, because at the end of the day, it is owning the LUN and it is also projecting the LUN out at the edge, right? So when time comes to take a backup, we appear as a provider to your backup applications. The common backup application SteelFusion appears as a provider for is Commvault through IntelliSnap integration to Semantic Net Backup, IBM Tivoli Storage Manager, whatever is your backup orchestration framework. Time comes to take a backup, you tell us it's time to take a backup for these LUNs. At that point, we send a signal out to the remote ESX blade, which is sitting on top of us, to take a VM snapshot. That VM snapshot is just to quiesce the virtual machine, right? Once the virtual machine is quiesced, I find out that in the block stream coming back, I insert a marker right behind it. That before this, everything is consistent because an application snapshot has taken place. After this, it's dirty, right? So once that stream arrives here, core sees the application marker or the snapshot marker. What it does at that point, it commits that data to the backend storage array. Then we trigger, because we have done we integrate with backend storage arrays. We trigger a snapshot on that LUN on the storage array to make sure it's consistent. Then we mount that snapshot onto a proxy ESX host, and then your backup application comes and journals and pulls out through VADP or whatever mechanism it is, updates your catalog, and then deletes the LUN and proxy unmount, and then the cleanup happens.
And then you commit the snapshot on the other side.
The other ESX snapshot we just deleted because we don't need it, because you've backed it up over here. Right. Okay. So that is the process of using existing applications. The advantage that you get from it is you don't have to deploy backup licenses or expensive replication methodologies, and use existing stuff that you've already paid for at the data center to just keep on doing that. Another advantage you get out of this is you can, for a system like a NetApp, if you happen to have a NetApp or any other storage system which does dedupe, the good point about dedupe is that it actually doesn't dedupe the file system tables. So you can keep all your VMs in a single volume and keep them completely deduped, right? And then once you project the LUN back to us, we'll have the metadata. So here, you can be lazy, because we are actually responsible for prefetching and serving it out. So you can maintain the same performance, but a massive dedupe at the back end to crunch the costs down. So that's the secondary benefit that people get out of it. Quick provisioning and disaster recovery, it's actually pretty simple. A lot of people have full-blown ESX licenses, full-blown storage, cloning licenses at the back end. It's just that they don't take advantage for that for their branch implementation. When you ship this SteelFusion converged, hyper-converged appliance to your remote office, another thing that you can do is you can highly automate your workflows, especially if you have very large distributed offices. So what you can do is you can clone the VM at the data center, and you can clone it using VMware. You can clone the LUN using your storage cloning methodology. Once you clone the VM, you can then boot the VM over the WAN. Depending if we understand the properties of the VM, about 90% of the VMs that are commonly used in branch offices, we've got that covered for you. We're also working on something called live journaling. What that basically means, if you provide to our professional services a sample of your VM, we can record the trace of it. And if we record the trace of it, even if that file system is unknown to us, we can definitely play it back to you, because now we have to play it back in between our appliances, right? So once that happens, you boot the VM on the remote side. But now imagine if there's a disaster out on the other side, right? And this is what a lot of people like about this technology as well, in addition to provisioning, right? If there's a disaster, you can just borrow external ESX servers at your data center, which you already have. Now this device has gone away. You can unmount the LUN from the core, present that LUN out to a local ESX server, re-IP it, and bring the service back up at the data center. And then you can tell the users to go to a coffee shop and log in over VPN. The service is degraded, but it is still available. And it is available in a matter of minutes. By the time you automate the appliance, you send the new appliance out to the remote site, you're back in business. And that's just unhook the VM from here, project the VM back out here, and you're ready to go. It's what I call data center sophisticated hard drive swapping.
There's a long stretch though in that minutes of you've lost your remote site to provision, ordering a new device, provisioning, warming, sending. That could be many days leading to weeks in order to get that out to that secondary site, right? The only reason I say this is because a lot of branch cases, there's no win in doing this if, depending on the size of the VM presence, you're better off to do local storage and do block level protection back to disaster recovery back at the core. Mm-hmm. So you've got the data locality. Like that's only reason, like I said, technically and cost wise, a lot of folks may battle this. There's probably a sweet spot where it makes sense.
Yes.
But it's challenging because when we talk about minutes to prefetch and send, there's a lot of other physical limitations on getting that device back out of your own branch.
So that is exactly what we battle in large-scale customers. What we allow them to do as a result of that is to make use of strategically located depots around the world. Because obviously, it's a $1 billion plus company and we have to have that platinum level of support. If the site is that critical, typically the data for that site is very critical as well. So generally what we feel is customer decides to consolidate that data completely, number one. Typically has a hot spare or an HA out at the edge, right? the recovery and the provisioning stuff that we have worked on is basically to remember what your working set is. So you don't have, so maximum, the getting the device from the depot out to you or powering up the hot sphere is the physical cost. Ideally, that's the maximum that you should be paying. After that, there's a lot of software work that we have invested in to actually understand your working set, push that out first along with the boot sector, so you're quickly up and functioning, and then we can keep on catching up to figure out what you missed over there. And that's a way we try to minimize that physical limitation that you, and sort of push that sweet spot a little bit further along the direction.
How much Riverbed participation is happening in the recovery back to that core where you have to push a VM back into a spare ESXi box, re-IP it, bring up that workload? How much of your stuff is involved in that process, or is that entirely, that's now my infrastructure?
Currently, if you don't use our PS, it's completely your infrastructure. What we can do is we can come in and script and automate that completely for you. But a major demand on us right now is to create this orchestration where you say, click, drag, service deployed. Right. That's what we're working on presently. Okay. And hopefully in the next tech field day, if he agrees with me, I should be able to demo it for you. And that's going to be like, click, provision out, fail back, provision back at the data center, right? In that case, we will also request you for a dedicated proxy host.
Right.
We got about a couple minutes left. More,
yeah, so
3 minutes. Yeah.
Right, and then we already talked about this recovered LUNs at the data center. This is what the appliance looks like. It comes in 2, 4, 10 terabyte flavors. In each of it, I don't know. Do you know what the SSD capacity on the 10 terabyte appliance is? There's about 1 terabyte's worth of read cache and read-write cache on top of it. These SSDs are capacitor backed, obviously to offset the cost of NVRAM. Another thing that you runs standard ESX. Has hardware bypass in it, so if the appliance fails, your WAN, this turns into a very, very expensive crossbar switch at that point. You can run any ESX-based application on top of it. Ideally, we want you to provision that application, populate that VM at the data center, project the LUN to the SteelFusion core, which is the broker, comes out here, you boot out here and start running. Ideally, if you'd use our professional services, we'd like to define templates and boot those templates out of remote sites to massively automate the cycle. State of Zen, this is what we want ideally to be at, where this is just stateless edges, nothing but a power cable and networking cable. Anybody can plug that in. From the data center, we're able to push OS, applications, and virtual machines out to the edge. The hardest part of this solution was not the engineering, but getting this PowerPoint to work in this way so that the VMs fly across. That was the hardest part, so I take credit for that. And then and ideally where we're trying to focus our efforts is to make it, because now we've solved the problem of disconnection, or attempted to solve the problem of disconnection, complete state consolidation, and LAN experience. So there is no reason that this has to be a data center on site. This can be AWS, where Core and SteelFusion Core and Steelhead are participating as AWS virtual machines up in the cloud, and we're presenting that S3 storage back down to you. So there's no data center backing up stuff that you have to do. Currently, we have customers actually testing that with the Amazon AWS gateway, where instead of having a back-end storage, they connect to that AWS gateway, and then that goes up to S3. But now we're being asked constantly, when can we just push this entire thing up? And for your non-critical stuff, which can actually go to the cloud, like such as your remote infrastructures, your regional data centers, you can just boot them, push them from the cloud, back them up in the cloud, and go completely data centerless. And another side benefit that you get from it, we decouple your data center and branch decisions. If there's a NetApp here, it need not be a NetApp there. We can take anything, S3, Swift, OpenStack, and project it out, whatever your choice of storage is. And I'd just leave you with this end slide, which is just some business benefits as to how a CIO justifies that he needs to look at it. Obviously, it's a cool technology, a lot of cool file system parsing. I can go about that all day long, but these are the reasons people cut the check at the end of the day.